Hallo, it's dumplet here. Here's an item on trigonometry. So simplify the following: the cube of tangent 15 degrees minus 3 times tangent of 15 degrees divided by 3 times the square of tangent 15 degrees minus 1. This item came from DAM 2022, an examination that dumplet has hosted. The link to the PDF file will be in the description. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. So essentially, we just have an expression in terms of tangent 15 degrees, all right? So, I mean, technically we can get tangent 15 degrees. It's not really that bad. So, I'll be showing two methods here. One is just the identities, and well, both are identities technically, but one is more straightforward. The other is kind of just using different techniques to get the answer. So, but the first method, the triple angle identity, it's not really obvious because, well, the triple angle identity is not really that well known. It's not really used in a lot of competitions. Probably the more well-known ones are the half angle identities and the double angle identities. Now, I'm just going to tell you guys that there is a triple angle identity for tangent, and it's very similar to this one. It's actually the exact same. So tangent 3x is actually tangent cubed x minus 3 tan x divided by 3 tangent squared of x and then minus 1. So, well, literally this given, but x is equal to 15 degrees. So essentially, this given is just equal to tangent of 3 times my 15 degrees. So essentially, this is just tangent of 45 degrees. So what's tangent of 45 degrees? That's just 1, and we're done here. But not everyone knows the triple angle identity, and well, I believe that you typically don't want to substitute tangent 15 into probably the triple angle identity, but we might try to do the second method, which is to use maybe the half angle identities to help us here. Well, I mean, technically the triple angle identity might be obvious because 45 divided by 3, that's 15. But maybe the half angle identity might be better. Now, just for some of you guys who want to verify that the identity is true, you could just use the tangent sum formula. So tangent of 2x plus x, and then just use the tangent double angle identity to just kind of write an expression in terms of just tangent x, all right? So yeah, all right, but the second method here is to simplify with the half angles, because you could argue that 30 degrees is half of 15 degrees. So we could kind of recall the sine and the cosine half angle identities. I'm just going to quickly write it here. So plus minus for both. And the difference of the two is just actually a sign. So 1 minus cosine x over 2 with the square root. For the cosine, it's just the same thing, except it's a plus, okay? So for the tangent, it's just sine divided by cosine. So tangent x over 2, that would be equal to, well, the sign is still unclear, plus minus, and then square root of 1 minus cosine x divided by 1 plus cosine x. Again, the sign is uncertain because of the sign of a certain function, well, either the sine or the cosine. It doesn't necessarily mean that there are two values for a specific answer, a specific value of x. It just means that the sign is uncertain. It's for us to find it out. Now, for us here, I'm just going to say that let's just square both sides. It removes of the, it eliminates the radical, and it eliminates the plus minus, the kind of ambiguity here. So I'll just have tangent squared of x over 2. Well, this goes away, this radical goes away, so essentially we just have 1 minus cosine x divided by 1 plus cosine x, right? So that's what you see here. And I know that I could substitute x to be 30 degrees to help me get what tangent squared of 15 degrees in this case is. So, well, x over 2 becomes 15, so tangent squared of 15 degrees, that would be equal to 1 minus cosine of 30 degrees divided by 1 plus cosine of 30 degrees. Now, since we know cosine 30 degrees is square root 3 over 2 from just special angles, well, I'll be having here that this would be equal to 1 minus square root 3 over 2 divided by 1 plus square root 3 over 2, multiplying the numerator and the denominator by 2, 2 minus square root 3 divided by 2 plus square root 3. We rationalize things here. We multiply 2 plus square root 3 in the numerator and the denominator. We will be able to get that the numerator just becomes, 2 minus square root 3, in the numerator and the denominator, like this, and then just simplify the result. We're going to get 2 minus square root 3 squared, and then in the denominator, we're just going to get 4 minus 3, and that's just 1. So essentially, tangent squared of 15 degrees is just equal to this one. So, but we know that tangent 15 degrees, it must be positive, because sine and cosine of 15 degrees are positive. They're both positive, because 15 degrees is in the first quadrant. So I could just take the positive root here. Tangent 15 degrees would have to be 2 minus square root 3. Technically plus minus of this expression, but since we know tangent 15 degrees is positive, we could just have tangent 15 degrees to be 2 minus square root 3. So it's actually not that bad of a value. It's prettier than the sine and the cosine of 15 degrees. So you guys could try to remember this one. Okay, so now that we have the value of tangent 15 degrees, we can try to just evaluate it. Now, direct substitution might not work, so I'll just propose that let's just set this to be x for now, and let's just say that we're just trying to evaluate whatever this thing is, okay? All right, so we could just do a similar trick that we've discussed on the channel before, and that is to, well, not directly substitute, but to make this a quadratic equation, kind of. So what I'm going to do is I'm going to put 2 on the other side, and then the negative square root 3 here. Now, it's hard to evaluate stuff with radicals. Well, here I'm going to cube it and square it if I directly substitute it. So that's pretty much a bad idea here. So what I'm going to do is to square both sides to eliminate of the radical. So let me just put it as x squared technically equals 4x minus 1. I'm going to write it like that. It's still quadratic, but I'm going to write it in that specific format because I'm going to do some factoring here to help me evaluate this expression. So x times x squared minus 3. And take a look at the terms that I'm highlighting. I have the x squared terms here, so I could try to plug x squared as 4x minus 1 in and then kind of solve the result. Okay. So x times x squared minus 3 becomes x times 4x minus 1 minus 3. So essentially 4x minus 4. And then we're going to divide the result by 3 times 4x minus 1 and then minus 1. Now the denominator here, it's going to be 12x minus 3 minus 1. So just 12x minus 4. So let's write that as 12x minus 4. 12x minus 4. And we can kind of see we have a lot of 4's here. 4, 4, 4, 12 and the 4. We could cancel a 4 out in the numerator and the denominator. So x times x minus 1 in the numerator. That's essentially x squared minus x. And the denominator is just 3x minus 1. Okay? Now the x squared here again, I could use 4x minus 1. So I'll have 4x minus 1 minus x divided by 3x minus 1. And then it just becomes 3x minus 1 in the numerator and then 3x minus 1 in the denominator. And this is just equal to 1. And as acquired in the first method, that is indeed the answer. So this is just a different approach because, again, the triple angle identity might not be as obvious. So probably we would try to do something similar to the second technique. Well, either you're going to directly substitute, which I technically don't recommend. But well, we can get around it just by using some nice algebra as seen here. All right? So hopefully you guys learned something new from this video, and I'll see you in the next one. Bye-bye.